Good morning, financial algebra. We are going to cover matrices, and this is a review from Algebra 1 and Algebra 2, but if you missed that, then you'll get a lot of review here. So 11.5 covers budget matrices. So here is an example of a matrix. It's a way to organize data, and I am going to label, when you look at things left to right, these are the rows. If we're looking at top to down, those are called columns. Now, when we name a matrix, we list rows by columns. So, example, this has 1, 2 rows by 1, 2 columns. Okay? This next one has 1, 2 rows by 1, 2, 3 columns. Okay? Now, also, A, B, C, and D are called elements of the matrix. So A is an element, B is an element, C is an element, and so on. So I went over dimensions, elements. Now how we name them. So if I was to list the rows here, I have row 1 and row 2. If I number the columns, I have column 1, 2, 3. So this matrix is matrix A. So I would say that A, and then at the very bottom, I would list row 1, column 1. So row 1, column 1 equals 1. A, row 1, column 2. So here's row 1, column 2 equals 2. A, 1, row 1, column 3, that equals 3. And then move on to row 2. So row 2, position or column 1. So row 2, column 1 is 4. A, row 2, column 2 is 5. And A, row 3, column 3 is 6. So I'm going to do a couple examples just like your homework, and I'm going to kind of go out of order. So number 3, what are the dimensions? Now remember, when we talk about dimensions, we're going to number the rows by columns. So in part A, I have 1, 2, I have 2 rows, but I only have 1 column. So this would be called a 2 by 1. B only has 1 row and 1 column, so this is a 1 by 1. C, I have 1 row, but I have 1, 2, 3, 4, 5, 6. So this is a 1 by 6. Part D, I have 1, 2, 3 rows by 1, 2, 3, 4 columns. E, 1, 2, 3, 4, 5 by 1, 2, 3, 4. Okay, moving on, we're going to identify the cell parts. So pretend that this right here is our matrix. Okay, so I'm going to label it by rows. Here's row 1, 2, 3, 4, 5, 6, and column 1, 2, 3. So what is the value of element C23? So remember the first number. This is row, this is column. So C23, here's 2, 3. So that would go here. What is C51? So 5, 1. What is the element of C6, 2? So that is 40. Which element has a value of 60? I see 60 here, and that is C5. column 3, which has an element of 90. So I see a 90 here, which would be C41. What would happen if in the elements in matrix 4C? That just means I would multiply each element, by 4. All right, we're going to go over a couple things. Sorry, I'm trying to find number 1. All right, so let's go over a couple things. In order to add and subtract matrices, I have to have same dimensions in order to add and subtract. So let's look at part number 1. Here are 3 different matrices. Here's matrix X, Y, and Z. What are the dimensions of Y? Y is a 3, 1, 2, 3, by 1, 2. List the elements of Z with their location symbols. So 1, 2, 3, 1, 2, 3. So Z11 equals 7, Z12 equals negative 2.5, Z13 equals 6. Z21 equals 3, Z22 equals 4, Z23 equals negative 5. Last, Z31 equals 5.2. Z32 equals negative 1, and Z33 equals 0. Now, we're going to do several different things with our matrices. So the first, they'd like us to add matrix X plus Z. So let's write matrix X. Matrix X was 2, 3, 6, 5, 0, 1, negative 1, 4, 1. And they'd like us to add matrix Z. Now notice matrix X is a 3 by 3 and matrix Z is a 3 by 3. So I can add them. This is defined because they have the exact same dimensions. So matrix Z is 7, negative 2.56, 3, 4, negative 5, 5.2, negative 1, and 0. Now, when we add, we have to match corresponding parts. So I have to add the top left number. I have to match it with the number I add over here. So the number in the second matrix, it's in the same position as this one. So that I would add those 2 numbers, and 2 plus 7 is 9. Next, I would add 5, the top middle, to the top middle in this one. So 5 plus negative 2.5 would go here, and that would give me 2.5. Then I'm just going to keep matching. Negative 1 plus 6 gives me 5. Next, 3, remember we're adding, plus 3 goes here. That is 6. 0 plus 4 goes here, and that would be 4. Okay, and then I would just keep going. So 4 plus negative 5 would go here, and that would give me negative 1. 6 plus 5.2 would go here, and that would give me 11.2. So hopefully you see the pattern there. It's not very difficult. 1 plus negative 1 would go here, and that's 0. And then 1 plus 0 would go here, and that's 1. And this matrix here is my answer. Okay. Now let's try a subtraction one. So because z is first, I have to write z and then x. I follow the order that is listed here. So matrix Z is 7, negative 2.56, 3, 4, 5, 5.2, negative 1, oh sorry, this is negative, and 0. And I'm subtracting matrix X, 2, 5, negative 1, 3, 0, 4, 6, 1, 1. Now remember, this time I'm subtracting. So be careful here. So I would have, and I'm going to organize my data. So 7 minus 2 would go here. Negative 2.5 minus 5. 6 minus negative 1. So these should match. So I did 7 minus 2, that went here. I did negative 2.5 minus 5, that went here. I'll simplify it in a second. 6 minus negative 1, that went here. So remember, we're always matching spots. 3 minus 3 goes here, that's easy. 4 minus 0, negative 5 minus 4. Negative 5 minus 4. Okay, again, I just matched 3 minus 3, that went here. 4 minus 0 went here. Negative 5 minus 4 went here. Okay, and I just continue to match spots. 5.2 minus 6. So we'll do 5, we'll open circle. Negative 1 minus 1 goes here. And 0 minus 1 goes here. So I'm going to simplify each piece. 7 minus 2 is 5. Negative 2 minus 2.5 minus 5 is negative 7.5. This becomes two positives, so 7. 0, 4, negative 9, negative 0.8, negative 2, negative 1. And this matrix here, let me move this over, is our answer. All right, so moving on, I'm going to skip to part F. 3y. 3y simply means I'm going to multiply 3 by the whole matrix of y. That easy. And matrix y, just a second, is 4.5, 10, 8, 9, negative 7, and 3. And this is called scalar multiplication, and we simply distribute, which means I'm just going to multiply everything by 3. So 3 times 4.5 gives me 13.5. 3 times 10, 30. 3 times 8, 24. 3 times 9, 27. 3 times negative 7, and 3 times 3. And so this is our new matrix. Really simple, okay? So the same, this would mean that I would simply distribute 0.5 times matrix X, which is 2, 5, negative 1, 3, 0, 4, 6, 1, 1. So again, I am distributing the 0.5 to every number. So that would give me 1, 2.5, negative 0.5. 1.5, half of 0 is 0, half of 4 is 2. Half of 6 is 3, half of 1 is 0.5, 0.5. Now last, in order to multiply matrices, the middle dimensions must be the same. So I can, if I have a 2 by 3 and I multiply that by a 3 by 1. If the two middle numbers are the same, then it is defined. The numbers on the outside will be the dimensions. Whoops. Of your answer. So if I want to multiply x times y, x, the dimensions of x are a 3 by 3. The dimensions of y are a 3 by 2. So because these middle two numbers are the same, I can multiply, so it's defined. And the result will be the outside numbers, a 3 by 2. So I'm going to go over how to multiply. It is kind of difficult. So matrix X is 2, 5, negative 1, 3, 0, 4, 6, 1, 1. And I'm multiplying that by matrix Y, which was 4.5, 10, 8, 9, negative 7, and 3. So hold tight. Here we go. I'm not going to do a 10. I take the top row, and I'm going to multiply it by the first column. And we're going to find the sum of their products. So I'm matching these first two numbers. 2 times 4.5 plus the next two numbers, 5 times 8 plus negative 1 times negative 7. I'm going to draw a line. Now I'm going to do the first row times the second column. Again, product of the first set, so 2 times 10 plus the second set, 5 times 9 plus negative 1 times 3. Now I'm done with that row, so I'm going to draw a line and I'm going to move on to row 2. So now I'm doing row 2 times column 1. Matching 3 times 4.5 is the first set of numbers, plus 0 times 8, plus 4 times negative 7. So you do the first, second, third. Now the second row times the second column. So 3 times 10 plus 0 times 9 plus 4 times 3. And I'm done with that row. Now the final, third row times the first column. So 6 times 4.5 plus 1 times 8 plus 1 times negative 7. And notice you'll see these numbers in parentheses should match. And then finally, third row times second column. So 6 times 10 plus 1 times 9 plus 1 times 3. And then I'm going to simplify each element. So 2 times 4.5 plus 40 plus 7. And I get 56. That's 20. 2 times 10 is 20 plus 45 plus negative 3. I get 62. Next, 3 times 4.5 plus 0 plus negative 28. And I get negative 14.5. 30 plus 0 plus 12. I get 42. Bottom, 6 times 4.5 plus 8 plus negative 7, and I get 28. 60 plus 9 plus 3, and I get 72. And that is the answer. So the reason I did that one is so that you could be able to answer number 4, where they're asked if each of these operations are defined. So let's go over each one. So part A, can I add matrix A to matrix B? In order to add, I have to have the same dimensions. A is a 2 by 4. B is a 3 by 2. So these do not have the same dimensions, so A is no. B, E is a 2 by 3. H is a 2 by 2, so this is again a no. If I multiply 4 times C, so I still have a 2 by 3, and 3E is also a 2 by 3. So even though I'm multiplying them by a number, it won't change their dimensions. So yes, this one is defined. So I can circle that one. E plus G, E is a 2 by 3, and G is a 3 by 2. So no, I cannot combine these. B times C. Now remember, these have to have the middle dimensions. So B is a 3 by 2, and C is a 2 by 3. And because these middle two numbers are the same, the answer is yes. A times F. A is a 2 by 4. F is a 3 by 3. These numbers are not the same, so no. A squared, so that would be A times A, which this is a 2 by 4 times a 2 by 4. These numbers are not the same, so no. F squared would be F times F. F is a 3 by 3. So because these two numbers are the same, yes. So you will have one like that. And then to conclude our notes, I believe I only have one more to do with you. So this takes all the knowledge, well, I'm going to do two more, of what we've done so far. So in order to solve these, I have to know how to add and multiply. So I determine the values of A, B, and C. So notice here's X, here's Y. This is the result after multiplying. So I know that row 1 times column 1 would give me this guy right here. So I'm going to set that up over here. I know that 3 times 1 plus A times 5 plus 2 times 8 would have to equal 24. And then I can solve. So I have 3 plus 5A plus 16 equals 24. So 5A plus 19 equals 24. That gives me 5A equals 5. So A equals 1. Next piece, I know that, now that I know A, I know that the second row times the first column would give me this number here. So I know that negative 1 times 1 plus 4 times 5 plus C times 8 equals 51. And just give me 2 seconds. So that gives me negative 1 plus 20 plus 8C equals 51. So 19 plus 8C equals 51. 51 minus 19. So 8C equals 32. So C equals 4. Sorry, and that is this setup here. Okay. All right, next. I know that this row times this column would give me this here. Okay, so I'm going to set that up here. And we already solved for A. So I know 3 times 6 plus A times 0 plus 2 times negative 2 has to equal B. But I already know what A is, so this is 18 plus A times 1 plus negative 4 equals B. So this gives me 18 minus 4 is 14 plus 1a equals b. Whoops. I know a is 1 and this is 0. So 18 plus 0 minus 4 equals b. So b equals 14. The last problem I'm going to do with you, like I said, I'm jumping around in here, is this one here. They'd like us to multiply matrix A times matrix B. So I have to list A first. This is a 1 by 5, and this here is a 5 by 1. So I am able to do it. But notice the result will be a 1 by 1, which is kind of crazy. So I have to write A first. So A is 80, 80, 80, 80, 80 times 1, 1.005, 1.0065, 1.008, 1.009, and 1.01. So remember, we match positions. So 80 times 1 plus 80 times the second 80 times the second number over here, plus now third 80 times 1.0065, One, two, three, four, five, six. Oh, I'm missing an 80. Sorry, this is a 1 by 6 and a 6 by 1. And then I have plus 80 times 1.008 plus 80 times 1.009 plus 80 times 1.01. And if you enter all of that, I got $483.08, and this represents an increase in fees. Phew, and that should cover everything you see.